Hello, I welcome you all to this wonderful lesson. This is a question based on ionic equation. So in this lesson, we are going to look at ionic equations and how we can answer such questions if they are to come in an exam. So I'm going to make this very simple so that you understand clearly. Let me say solutions. Before we go any further, I want you to understand that whenever you are looking at ionic equations, you only get to split those that get to be in aqueous state. For example, the first one there, we are going to split these ones that are in aqueous. We don't split those that are not in aqueous because we want to form an ionic equation. So the first part, you need to know how to write a complete ionic equation. So a complete ionic equation. How is a complete ionic equation? This is now where you just get to separate them without cancelling. So you split them. That is hydrogen like this. I put H there. That is the valence. So this is in aqueous. Plus, I move to a nitrate. That is a nitrate. That is a radical. I guess you know that's got a valence of 1, negative. That is the aqueous. I do this. Then I say plus. I move to this one. That is sodium and an hydroxide there. So sodium like this, that's got a positive there. Then it is in aqueous. Plus, that is an hydroxide. It has got a negative there. It is in aqueous, giving me what? This side, this is also in aqueous. So I split also that one. That is sodium plus, it is in aqueous. Then I say plus what? A nitrate, which is also in aqueous, like this, plus. Am I going to split water? No, there's no need of splitting. I just say water at the end, which is in liquid state. So this is a complete ionic equation. But if I'm told to write a net ionic equation, net ionic what? Net ionic equation. So for this question, you need to show everything. The same way I'm answering, that's how you are supposed to answer. You say complete ionic equation, net ionic equation, where you cancel out the things that are common. Not only the things that are common, you can end up cancelling out even those ones that are not in aqueous state. So we cancel those that are in aqueous state. So this is also here. Have you seen? We've got sodium there. Sodium is also there. So I guess these are the only ones. So we've remained with what? Hydrogen plus there, which is aqueous, plus I've got an hydroxide here, which is a negative. I say aqueous, giving me what? Giving me a liquid. So that is water, which is in liquid state. So meaning this is a net ionic equation. This is what I'm supposed to do. Just like this. As simple as this. Are we getting the concept? So the key thing here, some of you have got a question. How can I know that this one is carrying a positive? This one is carrying a negative. These are valences. When it is like this is a radical. Radicals are known. They've got their valences. You need to know. But this is an element. This is found on the periodic table where you know sodium is in group 1. So it forms a plus there. I guess you know valences. That's one of the major things that you need to understand. So this is the answer. We've answered the first part. We move now to the second part. We move now to the what? We move now to the second part. So let us now move now to the second part. So second part of the question. So let me say this is what? This is B. Let us move now to the second question. How can we write a complete ionic equation? A complete ionic equation will just be the same. Because this one, it will just be like this. Have you seen? So that is a carbonic acid aqueous reacting with what? Reacting with ammonia like this aqueous, giving us what? Giving us ammonium carbonate. So that is ammonium like this carbonate. This is it like this, which is also in aqueous. So you discover that this reaction does not dissociate into ions in solution, and it just remains as a what? Molecular equation. This is what we get to call a molecular equation. This is a molecular what? A molecular equation. It cannot form ions because you end up cancelling everything. Have you seen? So this is a molecular equation. There is no need of cancelling out. You just leave it like this, the way it is. So meaning that you just leave it like this. This is the answer. You just say, okay, this is the answer. It will just be like, it cannot form ions. It is just like this. We now move on to the last question that is here. We move now to the last question. So we've got this, let me say C. So I'm going to be quick on that one because we've gotten the concept, isn't it? So this one that is here, where we are told to say, we write an ionic equation. We split those that are in what? Those ones that are in aqueous. So what am I going to do? That is copper. This one will be splitted, and that one that is there. So what am I going to do? That is copper sulfate. So it is copper 2 sulfate because sulfate has got a valence of 2. So meaning it is copper like this, 2 plus. So here I'm not going to include my, okay, let me just include them. Okay, plus sulfate, that is 2 minus, which is the aqueous, plus then I've got 2, that is sodium, plus 2 is also applying to this one that is there, which is a negative like that, aqueous. Even here I put aqueous, giving me what this side? Copper hydroxide. So this one is a solid, it is in solid state, I no need of separating, plus then sodium, I say okay, that is sodium sulfate supposed to have a 2 here. Sodium sulfate needs to have a 2 there. That is sodium sulfate needs to have a 2 there. So meaning that the 2 will go on top. So 2, I do this, plus, then plus a sulfate, which is 2 minus. This is what, these ones are in aqueous. You put aqueous, even this one is in aqueous, the last one. So then aqueous. From here, you can, this is a complete ionic equation. For you now to write a net ionic equation. So a net ionic equation. For us to write a net ionic equation, what we are supposed to do, we just need to do what? We just need to cancel the ones that appear in on both sides, and we've made them ions. Sulfate, it is here. Sulfate, even sulfate there. We've got sodium here, even the sodium there cancelled. So meaning that I'm going to remain with what? I'm going to remain with the copper 2 plus, which is in aqueous, plus which other one? 2 hydroxide like this, negative, aqueous, giving me what? Giving me this copper hydroxide. So copper hydroxide like this, which is a solid. So meaning that this is a net ionic equation. It is just supposed to be like this. This one is a complete ionic equation. Complete ionic what? Equation. I'll say complete ionic equation. This is what we need to do, complete ionic equation. So this is where we are going to end from. I guess you've learned 1 or 2 things. So for those of you that are interested in starting tuitions with me, you can WhatsApp me on my number. This is my WhatsApp number. So drop a text on this number. I'm going to help you with your exams at an affordable fee. Don't forget, I do have a Facebook page. You can also follow me on Facebook to get all the updates that we get to do as an academy. So this is our official Facebook page name, Harrison J. Zulu Tutor. You can follow me on this page. Thank you so much. And for tuitions, don't forget that. Thank you.